So now if we go down to cryptography, we're going to start with password hashes here. And so if you look at a Windows machine, Microsoft Windows always uses the same password hashing system, and it's a very simple one. It is convert the password to Unicode and use 1 round of MD4. Because this system is so old, MD5 hadn't even been invented when Microsoft started using it. So the password of PASSWORD always has this password hash starting with 88. That's what it hashes to. So we can calculate those with Python, of course. So let's make a script. I'm going to call it hash1.py. And there. So like always, the reason everything is easy in Python is other people have done all the work for us. So somebody wrote a hash library, and we just have to figure out how to use it. And this is how you use it. You make a new object with the algorithm of MD4, and then you encode password and run it in there, and you can print the hash. So that's our first attempt. Let's try that. Python hash1. Okay, well, it created a hash object, and it printed the address to that hash object, but that's not what I wanted. I wanted the actual hexadecimal digest. So to do that, I have to run the Hex Digest method on it. So let's fix that. I have to do h.hex.digest. All right, that will give me the actual hexadecimal value of the hash. All right, now I'm getting a good-looking hexadecimal hash, but there's still a problem. It's wrong. It's supposed to start 8846, but this is 8A9D. And the problem is, the way I did it here, it took the ASCII string password and hashed it. But Microsoft, even since when this was all invented with Windows NT in 1993, Microsoft was already an international operating system, which supported non-English characters, but it used a really old version of Unicode called UTF-16LE, which uses 16 bits for every character, which is a lot less versatile than the UTF-8 encoding that we use now. But anyway, here's the code that will do that. So I'm going to call this hash2.py. I got to spell nano correctly. All right. And, it's this, there we are. Different paste keys on the different operating systems. So now I take password and I have to encode it with this UTF-16LE encoding, and then calculate the hex digest of that. So let's see how that looks. Python 3 hash2. And now I finally get the right answer, 8846 ending in 6C, and that is the right answer. So now I can calculate Microsoft password hashes. So make a loop and calculate the hashes for all 2-digit passwords from 00 to 99. You'll have a little bit of difficulty dealing with the leading 0, but there's a variety of ways to do that. And you get this list. So find the hash containing this string, and that hash value is the flag. And then you can start cracking Windows hashes. I have 3 users, and I have a pattern for the input, so there's only 100 possible passwords for each one, so you can crack these hashes. Now, these are taken from a real Windows system, and the way Microsoft Windows hashes are stored, first there is a really old system called the LM hash, which is no longer used, but they leave this value here as a placeholder to keep the format consistent with older versions. So this does not contain any information, and as you can see, it's always the same. It is this part of it that is the NT hash that we just described, NTLM hash. So that hash contains the information for the password, and you'll be able to find it by calculating 100 options and seeing which one matches this. And then you can try other algorithms. This 1 round of MD4 is a terribly weak algorithm, 1,000,000 times weaker than what Linux uses or the Mac these days. So you can try other ones. Here's MD5 with several rounds, less than 100. So now you have 100 possible passwords, and you hash it over and over and over again, up to 100 times, so you might have as many as 10,000 hashes that you have to hunt through for a match. And you will find out these hash algorithms are so fast, that's not hard to do in Python. And here, you have even more rounds of MD5 followed by more rounds of SHA-1, and again, you can still crack it without much trouble. And here is from a modern Linux system, Debian 10. These password hashes look quite a bit different. They're in base 64 instead of hex, and they're much longer, and it starts with this number 6, which tells it what type of password hash it is. And that you can do with the crypt library, and it will calculate these hashes for you. So again, you can crack some Linux hashes. And you'll see that they take a lot longer to crack because by default they have 5,000 rounds of hashing to make them 5,000 times slower. And here is Lastpass. Lastpass, the master password in this password manager, uses 100,000 rounds of hashing. And you can still crack it with Python as long as you don't have too many options to try. So there's a few password hashes to solve. I'm going to stop this one.